Okay, today's lesson is on trig functions 4.2a. There will be 4 email questions. In this lesson, you will evaluate the 6 trig functions using the unit circle. Okay, this is your SOHCAHTOA. Most of you should know these. These are the abbreviations for these words here: sine, cosine, tangent, cosecant, secant, and cotangent. The cosecant is the reciprocal of sine, the secant is the reciprocal of cosine, and the cotangent is the reciprocal of cotangent. See how this is opposite over hypotenuse, hypotenuse over opposite. One way to remember these is that S goes with the C and the C goes with the S. The S does not go with the S. Alright, and of course the cotangent goes with the tangent. And for this arrangement here, where the angle theta is in this right corner, right lower corner, the opposite side is the farthest side away from your angle, and the adjacent side is the side next to your angle. And the hypotenuse is always the long side, or the one away from the right angle. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's how we get SOHCAHTOA. Okay, and then you just have to remember that these are the reciprocals of those. Alright, use a calculator to evaluate these expressions to 4 decimal places. Find the sine of 6 pi. Actually do this on your calculator, because we find that people are not very good at producing these on their calculator and don't know how to use them. You're just pushing buttons, and because now we're at a point where the answers aren't that intuitive. Like if you put 2 plus 7 on your calculator and you got 18, you know you got something wrong and you can go back and check. Well, if you get the wrong answer here, you don't intuitively know what the answer is, so you just write it down, so be careful. Alright, so that's 1/2 or 0.5. Notice that this is in radians because there's no degree symbol. Whenever there's no degree symbol, it's automatically radians, and your calculator has to be in radians. Tangent of pi over 2, that's undefined. Okay, and cosecant of 1.3, you notice that this does not have a pi, but it's still in radians because there's no degree symbol. So your calculator should still be in radian mode. And on this one, you'll be actually taking the sine of 1.3, and then you just take the reciprocal. Or one way to put this in your calculator is to put 1 divided by parentheses sine of 1.3 close parentheses. And that should be 1.0378. What about the cosine of negative 97 degrees? Okay, now it has a degree symbol. Make sure your calculator is in degrees. And you should get negative 0.1219. What about secant of 1.8? Again, this is in radians because it doesn't have a degree symbol. And this will be the reciprocal of cosine, so you put in your calculator 1 over cosine of 1.8. Okay, and you should get negative 4.4014. And the cosine of negative 160 degrees should be negative 0.9397. And the sine of negative 1.34. Okay, hopefully I didn't catch you doing this now that this is in degrees and this is not. And this is tangent of 1 degrees, and that is 0.0175. Okay, email these 3 answers or 2 answers, rounded to 4 decimal places. Okay, find the exact value of the 6 trig functions for this point up here, 5, 12. And we're really talking about an angle that's swept out from the positive x-axis. So this is 5 going out this way on the x, 12 going up and sweeping up from the x-axis. It makes this angle theta in here. And if you look at this, hopefully you can see that this is a triangle, a right triangle. And we have the 12, which is the height of my triangle. 5 is the base. So now if we're talking about this angle and we want to find the trig functions, we need the hypotenuse, the side that I don't know. And how we find that? The Pythagorean theorem. Okay? A squared plus b squared is equal to c squared. 25 plus 144 is 169. Take the square root of 169, you get 13. So now if I ask you to find the cosine of theta, you would say cosine is adjacent over hypotenuse, which is 5 over 13. Sine of theta would be 12 over 13. Tangent of theta, that would be adjacent or opposite over adjacent, 12 over 5. And then cosecant, you can look over here or you can just look over here. It is a reciprocal, so it will be 13 over 5. Cosecant would be 13 over 12, and cotangent would be 5/12. Very good. Find the 6 trig functions for this triangle right here, and theta's right here. So sine is opposite over hypotenuse, which is opposite from the angle over the hypotenuse is 13. Cosine, well, we know from the Pythagorean theorem that this is going to be 12. Right? A squared plus b squared is equal to c squared. A squared plus 25 is equal to 169. A squared is equal to 144, and a is equal to 12. So now we have the adjacent to the angle would be 12 thirteenths. Tangent is opposite over adjacent, be 5/12. Cosecant, 13 fifths. The reciprocal of this one. Secant would be 12 thirteenths, and tangent is 12 fifths. What about this here? 9, 15. And the 6 trig functions. We need a. So a is a squared plus 9 squared plus 15 squared. Be a squared plus 81 is equal to 25. And then subtracting 81 from both sides, we get a is equal to 12 again. Alright. By the way, these 3 numbers here, because all 3 fit in the Pythagorean theorem without any decimals, this is called the Pythagorean triple. Okay, 3, 4, 5 make a Pythagorean triple. 5, 12, 13 make a Pythagorean triple. Okay, those are good to know because you'll see those over and over again because there's not too many in the low range. And people who write problems for these triangles, right triangles, always use these same numbers over and over again. So if you memorize some of them, it'll make your life a lot easier. So sine of theta is opposite over hypotenuse, which is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent is opposite over hypotenuse, or opposite over adjacent. Cosecant, reciprocal of sine. Secant, reciprocal of cosine. Cotangent, reciprocal of tangent.